Hello, chemistry. Welcome back. I am not here today, but I am still going to walk you through the output page that you will be working on. So, this comes with a few directions. One, put your name on it, please. And two, let's start with the 3D Lewis structure. Now remember, Lewis structures can only be 3D if they have 4 things bonded to the central atom, meaning that it's a tetrahedral electron domain geometry. Okay? So keep that in mind as we work through what I'm about to show you. So we'll do the first one together. So this says draw the 3D Lewis structure for CO2. Okay. So CO2 is going to look like this. It has a double bond. Okay. If you are confused on how to do Lewis structures at this point, please come see me. But please note that these double bonds and this double bond comes from the fact that carbon's got 4 electrons around it, oxygen has 2 spaces where it can make bonds, and so does this one. So in order to fulfill what carbon needs, it needs to make double bonds with those oxygens. Now, let's determine what its shape is. So carbon's a central atom. It has 1 thing attached to it over here and 2 attached to it over here. So its shape is linear. So this does not have a 3D structure. That's it. So this is a 3D structure. You can't make a 3D structure out of a line. But what I want to also mention is we needed to color code, which I did not do, my apologies. We need to color code nonpolar bonds and polar bonds. And this is going to be true for all of these. Okay? So once we get here, we need to determine if these are polar bonds or nonpolar bonds. So if you go into your gold packet, I give you the electronegativities of every single atom. You can hear me probably flipping to it right now because I don't have them memorized. So a carbon to oxygen bond, oxygen has an electronegativity of 3.5. Carbon has an electronegativity of 2.5. giving me an overall difference of 1.0. Now, this falls within 0.5 to 2.0. Okay? So, I know, and I'll make, polar bonds red, nonpolar bonds are blue. Sure, why not? Okay? Well, I just determined that these are going to be polar bonds. Okay? These are going to be polar bonds. So that's the first part. Okay, I drew the Lewis structure. I determined if my bonds are polar or nonpolar. So let's look at what we need to do. Color in the bonds, just did that. State whether the molecule overall is polar or nonpolar and explain why. Okay, so now I've determined if my bonds are polar or nonpolar, but now I need to determine if the molecule, not the bonds, the molecule itself is polar or nonpolar. Overall, this molecule is nonpolar. The reason being is it is symmetrical, meaning that both sides match up. Sorry, butchered that word, but you got the idea. So if you're still confused, if you look at this, and since it's nonpolar, you don't have to draw the dipoles. You only need to do this if it's polar. Okay? But for me, I'm just going to do this to explain why. So the reason that this is nonpolar is due to the fact that even though the oxygens are pulling on those electrons, and there is an electronegativity difference, it balances out. I have an equal pull from this oxygen and an equal pull from this oxygen. So basically they cancel out, and it causes the overall molecule to be nonpolar, even though it is made up of polar bonds. Okay? So for the other two, I would like you to do the exact same thing. If there's a 3D Lewis structure, go ahead and draw it. And then calculate the bond differences. Tell me if it's polar or nonpolar and explain why. And if it ends up being polar, include the dipoles in there somewhere. So there we have water, and then down here we've got carbon with a hydrogen and 3 chlorines. If you have any questions, please do not hesitate to reach out. I will be happy to help you in the best way that I can. I will reply when I can, and I will be grading these on Monday, cherubs. Good luck, and please communicate if you have questions.